In Lesson 3-4, we will be covering parallel and perpendicular lines. Take a minute to read over the learning goal and look at the scale. See where you are before we start the lesson. Remember, your target is to be at a level 3 by the end of the lesson. We can use the relationships of two lines to a third line to decide whether the two lines are parallel or perpendicular to each other. Let's take a look at Theorem 3-7. If two lines are parallel to the same line, then they are parallel to each other. Since line A is parallel to line B, and line C is parallel to line B, line A is parallel to line C. Check out the real-life examples below. As we read Theorem 3-8, let's consider why the phrase "in a plane" is important. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So, if line M is perpendicular to line T, and line N is perpendicular to line T, then line M is parallel to line N. Remember, lines that are non-coplanar and do not intersect are skew. So we have to make sure in Theorem 3-8 that we use the phrase "in a plane." Let's do a quick proof of Theorem 3-8. Let's start with the given. In a plane, line R is perpendicular to line T, and line S is perpendicular to line T. Since we know the definition of perpendicular is to form right angles, angle 1 and angle 2 are right angles by definition of perpendicular. In step 3, angle 1 is congruent to angle 2 because all right angles are congruent. And finally, since angle 1 and angle 2 are corresponding congruent angles, line R is parallel to line S because of the converse of the corresponding angles postulate. In example 1, we will be solving a problem with parallel lines. A carpenter plans to install molding on the sides and top of a doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angles as shown. Will the pieces of the molding be parallel? Explain. Since we know the angles at the connecting ends of the molding are 45 degrees, we now need to determine the side pieces of the molding are parallel. Since 45 plus 45 equals 90, and 45 plus 45 equals 90, both side pieces are perpendicular to the top piece. If two lines are perpendicular to the same line, or in this case the two sides are perpendicular to the top, then they are parallel to each other. Pause the video and do you try number 1. Can you assemble the pieces at the right to form a picture frame with opposite sides parallel? Explain. If we place the pieces with the 60-degree corners opposite each other, like at the top and the bottom, and we place the pieces with the 30-degree cuts opposite each other on the left and the right, then 60 plus 30 will equal 90, 30 plus 60 will equal 90, 60 plus 30 will equal 90, and 30 plus 60 will equal 90. Since all corners will be perpendicular, then the opposite sides will be parallel. Now that we've seen two theorems that allow us to conclude that lines are parallel, let's take a look at the perpendicular transversal theorem. This theorem allows us to conclude that lines are perpendicular. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So, if line N is perpendicular to line L, and line L is parallel to line M, then line N is also perpendicular to line M. The perpendicular transversal theorem states that lines must be in a plane. The diagram below shows why. In the rectangular solid, line AC and line BD are parallel. Line EC is perpendicular to line AC, but it is not perpendicular to line BD. In fact, line EC and line BD are skew because they are not on the same plane. In example 2, we will prove a relationship between two lines. Let's start with the given. In a plane, line C is perpendicular to line B is perpendicular to line D, and line D is perpendicular to line A. We want to prove that line C is perpendicular to line A. Our second step is that line C is parallel to line D, because two lines that are perpendicular to the same line are parallel. Step 3, line D is perpendicular to line A because it is given. And in step 4, we can say that line C is perpendicular to line A by the perpendicular transversal theorem. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Pause the video and do you try number 2. In example 2, could we also conclude line A is parallel to line B? Explain. Sure. Since line A is perpendicular to line D and line B is perpendicular to line D, line A is parallel to line B. In a plane, two lines perpendicular to the same line are parallel. Now is your chance to test what you've learned in this lesson. Pause the video and do the lesson check now. Don't forget to check your answers on the next slide. If you have any questions or are unsure about anything from the lesson check, make sure you ask me tomorrow in class. If you're feeling up to the challenge, go ahead and give it a shot. I'm pretty sure you can handle it. Now take a minute to reread your learning goal and look at the scale. Have you met the target goal of a level 3?